This method is technical and a bit less accurate than the one that we had in a previous audiovisual. But because of the particular values, the answers will turn out to be exactly the same. First, find the unknown angle A. We are required to find the length of ED. That's what we are required to find. And we are using an alternate method in finding the length of ED. We will therefore find the angle A. Remember that on previous audiovisuals, we assumed that the size of the angle A was 35, but that was just an assumption used as an illustration. We are going to find the actual size of that angle. We will find the angle at A. In the large triangle, BC is opposite to angle A, as we can see. We have the large triangle, we have BC or CB, BC is opposite to the angle at A. Also, we have this side, 8 meters, which is adjacent to that angle. We have opposite and adjacent, and the trig ratio that we use in opposite and adjacent is tangent. Not only that, but it is noteworthy that tangent is opposite over adjacent, because it cannot just be tangent. We have to be sure what tangent is equal to. Opposite over adjacent, and we have the opposite in blue right there, and the adjacent in red. So opposite is 6, adjacent is 8. Tan of A, or tangent of A, is 6 over 8, which in decimal fractional form is 0.75. We have the tangent of the angle. To find the angle, we need to take the reverse of taking the tangent. And the reverse of that process is to take the tan inverse. We will therefore take the tan inverse of 0.75, and let's see what the angle A is equal to. A is equal to tan inverse of 0.75, which is equal to 37 degrees. And as we say, hindsight is 20/20, because in the long run, we will see that we did not really have to find the actual angle A, and we will see that in a few seconds. We have the angle A. In finding DE, we will make use of the smaller triangle, of which DE is one of its sides, and also the analogy that exists between the two triangles. There's an analogy between the two triangles in the same way. Opposite over adjacent. Let us reflect on that quickly. See that? Opposite over adjacent. We will have again opposite over adjacent. Like that. In finding DE, we will make use of the smaller triangle and the analogy that exists between the two triangles. Opposite over adjacent again, and that is equal to tangent of the same angle. Opposite over adjacent. What is opposite? Opposite on this occasion will be DE, and the adjacent will be AD, which is known to be 4.8 meters. Tan A is equal to 0.75. This is what I mean when I said that we did not have to actually calculate the angle. Why? Because we are using tangent of A in the first case, and here again we are using tangent of A. Therefore, instead of finding the angle, we could just use the value of the tangent, because the value of the tangent is just going to be the same. Notice, tan A is 0.75, and we have the 0.75 right there. We did not have to actually find the angle. DE over 4.8 opposite over adjacent, and that is equal to the 0.75 that we have here, which is tangent of the angle irrespective of which of the triangles we are in. Eliminate 4.8 that is accompanying DE on the left hand side by division. This DE that we have here that we need to find is accompanied on that left hand side by 4.8. We will eliminate this 4.8 that DE is being divided by multiplying by 4.8. We will have to balance the equation by multiplying by 4.8 on the right hand side. As a consequence, the 4.8 will be eliminated from the left hand side, and on the right hand side we will have 0.75 multiplied by 4.8, which turns out to be 3.6 meters. In using this method, additionally, we had to find AD, which was a requirement in a previous section. We therefore did not have to find the length of the side AD right here, because that was a requirement in a previous problem, and we found that value to be 4.8 meters. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.